We are given this diagram. We're asked to find the radius of the inner circle. The question looks very tricky, but it's easy. So this is an equilateral triangle because since here is 60, they give us an isosceles triangle, meaning the base angles are the same, they are equal. Since it's 60, meaning each should be 60 to make it 180. So this angle is 60. This is also 60. Need to join some points. So let me first join B to E. So by joining this, we have two similar triangles because here is also 60 degrees. By Bow's theorem, there's angle in the same segment, 60, 60. They have the same intersected arc, so 60, 60. And if we call here maybe theta. So let's redraw, let's draw the two triangles that are similar. Here should be 60. This is 60 minus theta. Yes, because this is 60. This is 60 plus theta. So this should be 60 minus theta to make it 180. Again, this is 60. This is 60 plus theta. So here should be 60 minus theta. So we have two similar triangles. Let me draw it so that you won't get confused. So the first triangle is triangle ABE. So this is B. Sorry, this is A. This is A. This is B, and this is E. The angles are this 60 minus theta. Why this is 60 plus theta? Y here is 60. So why the second one is the big one, which is A, B, D. This is 60 plus theta. This is 60. Why this is 60 minus theta? So the two triangles are similar as the interior angles are congruent. So we see that triangle, the length here, the length here is 9, while the one A is 4. So let's call the side we are looking for A. So let's call the side of this, because it's an equilateral triangle. Let's call the side A. Let's call ABA. Let me use it here because I will still use here. So the sides AB, this is A. So, okay, we see that A, that's AB of this small triangle. Remember, here is also A. A of this small triangle corresponds to which one in this big triangle? This 60 plus theta, this 60 minus theta. 60 plus theta, 60 minus, so it's 9. Equals AE, which is 4, corresponds to which one here? This is 60 plus theta, this is, which one is 60 plus theta and 60, which is A. This is A. Therefore, A squared is 4 times 9, which is 36. Our A is 6. So the length of the side, remember all the sides are equal. So that's the first thing we'll get here. The second thing now, the radius of the in circle. Before I relate it, let's analyze something using this diagram. This is an equilateral triangle inscribed in a big circle, and why an in circle is there also. So if we join some points, so as you can see, the side is like a tangent line to the circle. It's tangent to the circle, so the radius is perpendicular to that. So this is the radius, let's call it R. And remember, from our basic geometry, if you want to inscribe a circle, you need to bisect two angles. The point of intersection is the center of the circle. So meaning that this is now 30 degrees each. This is also 30. So we form a 30, 60, 90 triangle. So the theorem is easy to understand, that if you are given a side opposite 30 degrees, the one opposite 60 is just R times root 3. So the side times root 3, I'm saying from here to here, is that. So that same way, this R times root 3. Why the one opposite 90 is just the double of the one opposite 30. So OC is 2R and OB is also 2R. So and that 2R happens to be our circumradius. That's the radius of this big circle. So we can still, because there are some important things we need to, this is also 2R. So you see that the height of this equilateral triangle is 3R. That's 3 times the radius of the in circle. So we see that the first thing, that the height of the triangle is 3R. That's R is the in radius. So the second thing we are going to see here is that, remember the side, assuming we call the side of the triangle to be A. So here is also A. So we see that the side is now 2R times root 3. Yes, if you add R root 3 plus R root 3, that gives the side of the equilateral triangle. So whenever equilateral triangle is inscribed in a circle, we can relate the circle and the in circle. So let's go over to let's finish up the equation. So since we've known the side of the triangle to be 6, from what I've just said now, that the side of the triangle is 2R times root 3. That's radius of the, where R is the in radius. So we substitute A is 6, so we have 6 equals 2R times root 3. And I can write 6 as root 2 times root 3 to simplify our solution. So root 3 is root 3. Therefore, R is, root 3 is gone, so we are left with root 2 over 2. So our answer is option A. So we have enough information, is A.